Here we go. Okay, guys, we are doing 7.1. We are graphing systems of equations. Okay, make sure you are taking notes. You are going to be happy if you do. Trust me. Now, what's funny is I keep all my notes from year to year, and what's strange is I'm missing some notes from last year. Luckily, I kept saying, well, gosh, it seems like there's more that goes with this, and sure enough, I found 2 years ago the rest of my notes. I'm doing about 3 pages is all. I'm going to double check. I'm going to just double check because that just seems weird. No, I think I got the wrong notes here. Of course I do. What is this? Y'all, just wait. Hold on. No, maybe I'm wrong. Yeah, I think I'm wrong. I think I was right the first time. What is this? Why is this here? All right, I got to pause this. Start over. We're back, Ariel. And I was correct, because what everyone wants to know. I want to go on record. Okay, so here we go. I don't have a whole lot of notes. I do have the correct ones, though. Let's get started. We're graphing systems of equations. Let's just talk about that. How you, solving a system by graphing. I'm going to underline graphing. Okay, these are the steps to solve a system by graphing.
You put an example?
Oh, no, I'm going to do the steps.
Oh.
Okay, step 1. Now, if I'm going too fast, you need to raise your hand or say, oh, wait, Miss Rogers, or something like that, because I don't want to leave anyone behind. All right, so step 1, you're going to graph both equations. So if it says both equations, how many equations are you dealing with?
2.
There you go. On the same coordinate plane. Honestly, I'm a graphing person. I love doing it this way. I have to teach you how to solve systems of equations by like substitution and stuff like that. That's where we get in all that writing. To me, this graphing just makes sense to me. So those of you that enjoy graphing are going to love this method here. But we are dealing with 2 equations. When we graph equations on coordinate planes, what format do each equation need to be in? That's right. Y equals mx plus b. Slope-intercept form. Or just call it y equals mx plus b form. I don't care.
So this section should be the easy one, the little one?
7.1 is going to be, in my opinion, it's my opinion. Some people may not like it, but it's going to be easier. It's the little boy. There you go. So the first thing you do is graph both equations on the coordinate plane. I didn't spell coordinate correct. Why didn't y'all say something? Y'all just sitting there laughing. Okay, thank you. Step 2, identify the solution. The coordinates of the point of intersection. Solution is like your answer. Okay, you're going to identify the solution, which is the coordinates of the point of intersection. Now I'm going to explain that in more detail. In fact, that's the next thing I'm writing. The solution, and then I'll pause and let y'all catch up, is the point of intersection. Yes, you've written it. Write it again. Of both lines or graph. Basically, where the two, remember you have two equations you're graphing. Where the two cross, that point, that ordered pair, that's your answer. Point of intersection is where the two graphs cross, that ordered pair, that point, that is your answer. Point of intersection is where the two lines, which are equations, meet or cross. You need to make sure, I'm giving you time to write this down. You need to make sure you write this down nice and neat. If you need to like underline it, star it or something, that's a lot of explanation for number 2, but it's the wording. Identify the solution. Okay, it's the ordered pair where the two graphs or the lines cross. And step 3, which no one ever does.
Do they get it wrong if they don't do it?
No.
Check it.
Checking. Check the solution, which is the point of intersection, ordered pair, by substituting it into each equation. Now, you can do that. If you want to make sure you make a good grade, you can. But really, I'm going to show you how this is done. It's not difficult. So when you get that written down, just put your pencil down, rest your hand, and then I'll know you're done. And then we're going to start on examples. Like I said, I have just a few. Good job, Franz. I have just a few examples because this is not difficult. It's more time consuming. Who knows?
What?
Who knows? It won't hurt you, Franz, I promise. I'm not feeling evil, but I do want to keep moving, so I stay on track. You good back there? If you want to move into that middle desk, you know you can. You know the one that's closer to chat? That's a totally empty. Is that where Ariel usually sits? Okay, well today you can totally sit there if you want. It's up to you. Okay, just stay awake back there. All right, here we go. First example. We're going to solve the system by graphing. You need to write down these words, because when it's on a test or something and you're not familiar with it, what are they asking me to do here? What does that mean, solve the system by graphing? You got to get familiar with what they're asking there. Okay, let's say you have x minus y equals -5 and 3x plus y equals -7. Write this down, Franz. X minus y equals -5 and 3x plus y equals -7. Okay, so those are your two equations that they gave you. And they want you to solve the system by graphing. What is the system? Well, we're going to find that out. Now, I know y'all hate writing, but I'm writing more notes. Just as a reminder for when you're doing your homework, you are looking for the point where these, I want to make sure you know what you're doing, you know, the whole goal. You're looking for the point where these two lines cross. Answer will be an ordered pair. So your answer is going to be in the form of an ordered pair. Franz, can you get me some graph paper? One piece of graph paper, please.
One?
Yeah, just one. Thank you. Thank you, dear. Yes, you're graphing, so later on, y'all don't need to be precise in your notes. Make sure your drawing looks good, your graph. But in your homework, you are going to be needing to use the graph paper. Yeah, if you want to get some now, you can, or whatever. And you're using rulers. Okay, so now that everyone has this, we have to solve the system by graphing. So step one is what, Keith? What do I do with these? And how do I do that? What do I need to do to these first? That's right. We need to put them both into y equals mx plus b format. Okay, so both of them. So I'm going to write the first one right here. And the other one right here. Neatness does count on this. Okay, and y'all can go about changing it to y equals mx plus b. So let's see. Franz, what do I need to do to put this equation?
Move x to the other side.
Very good. How do I do that?
Subtract x on both sides.
Good job.
And we go -y equals -x minus 5, and then move
Wait. Okay, he's correct. So far we're on the right track. Make sure that x is first. But Franz, go ahead.
Like move the negative symbol to both, like the x.
Apply
and
it to here. So what, you can't have a negative y, so this now becomes y equals what?
X plus 5.
X plus 5. Okay, so this, and I'm going to circle it, that is line 1. And I'll let y'all catch up. That is line 1. Those of you in the back, that says line 1. So line 1, the equation is going to look like this. Are there any questions? Okay, so let's do this next one. Valeria, tell me how to put this one into y equals mx plus b. Very good. See, y'all should be able to do these in your sleep now. And it becomes y equals. Perfect. And it's good to go. That is going to be your line 2. Okay, so I have my 2 lines. Now we're going to graph it. So what is my slope for this one? Keith,
What?
what's my slope for line 1?
1.
Very good. You can even say 1 over 1. And what's my y-intercept, Keith? Very good. Miranda, what's my slope for this line? Good job. And my y-intercept is what, Sophia? -7. Okay, I'm going to let y'all catch up. Put your pencils or pens down when you are done, so that I know you're ready. Don't. Everyone good? All right, so I'm drawing my graph, my Cartesian plane. Here's my x, here's my y. Now I want you to graph both lines on the Cartesian plane. Wake up.
Oh, wait,
You, okay, good. All right, so the first one is y equals x plus 5. So what do we post first? What do we point first? What do we put on the graph first? The y-intercept. So that's going to be positive 5. 1, 2, 3, 4, 5. So I put a dot there. The slope is 1, basically like 1 over 1. So 1 over 1. We could go the opposite direction. Now this one, okay, and I hope Ariel's listening. This chapter, you can't just do 1 or 2 dots. I'm going to strongly suggest you do as many as you can to get an accurate line. If you do not graph these perfectly, it will cost you your answer. Trust me, I make mistakes too. All right, so here's one.
Why are you going down if it's a positive one?
Because you can also do negative over negative.
Oh.
-1 over
I
-1.
wasn't understanding the part.
Oh, no, I'm glad you asked. All right, so there's 1. And now we do, yes, ma'am? Because we're not doing inequalities. Good question. If it's an inequality like less than or greater than, that's when it's dashed or solid. Good question. So the second line, my y-intercept is -7. 1, 2, 3, 4, 5, 6, 7. So I'm going to put that point there. And then the y-intercept, the slope is -3. So down 1, 2, 3, and over 1. Or we can go up 1, 2, 3, and over 1.
Oh, so it's not.
So remember, the slope was -3. So it can be either -3 over +1, or you can do +3 over -1. Either one gives you the same answer. So now I'm going to very carefully do you see now why you need to have as many dots as possible? Oh, there we go. If yours did not line up perfectly, then you're going to need to do more points to make sure you draw those lines accurately. So make sure you have your graph. Now, notice, everyone look here. Franz, look here. See where the 2 lines cross?
Mm-hmm.
That is your point of intersection. That's your answer. Now, what ordered pair would that be, Morgan.
2, sorry. Well, like, it's x and then y.
Uh-huh.
Negative 3, 2.
So your answer is going to be in the form of an ordered pair. So it's 1, 2, 3. So it's negative 3 and then up 2. So that is your answer. Now I'm going to write answer. Nope. So that's what you're doing today. You're first taking the two equations, putting them in the y equals mx plus b. You're graphing them, and you're going to have to be very careful with your graphs. The more points you plot, the more accurate your lines are. Okay? Now, again, I would use each one as its own still. Make those graphs nice and neat. Wherever they cross, you write down that ordered pair. If it crosses at a weird spot for today, if it crosses like in the middle and not at an intersection, something's probably wrong.
Question, when is it? When we get into science?
We're not in science. Does everyone have this? Any questions? So that's what you're doing there. You're graphing them, and then wherever they meet, that's your answer in an ordered pair. Do we understand that? All right. So that's going to go with that. Let's do another one.
Oh, that was example 1.
Solve, I don't have that many. The systems by graphing. All right, your equations are x plus y equals 3 and 2y equals negative 2x plus 6. All right, so what's the first thing that we're supposed to do, Valeria, after you get done writing it down?
No, negative x.
Well, we're going to do what to these equations? Yeah, so what do we need to do to be able to graph them? Put them in what form?
Y equals mx plus b.
Perfect. So I'm going to rewrite them by themselves. So I have room to work. And we're putting them in y equals mx plus b format. Write that down right here. Okay, so Valeria, you said, how do I put this into y equals mx plus b?
Negative x.
Perfect. On both sides. Y equals negative x plus 3. That is our line 1. Keith, tell me how to put this one. By everything. We're going to divide 2 with all of them. And I'm left with y equals,
Negative 2 over
oh,
negative x plus 3.
very good.
Oh.
And this is your line 2. All right, what do y'all notice about this? Raise your hand if you see something, chat. Ah, look, guys. Y equals negative x plus 3. If you had done y equals negative 1x plus 3, is that still the same thing?
Mm-hmm.
Yes, same. Okay, so if it's the same thing, then what is it?
There's only one line.
Bingo, Franz nailed it. They are the same line. So if it's the same line,
Then you have the exact same
guess
answer.
what your answer is?
Negative 1.
The solution or the answer is y equals negative x plus 3. That's your answer. That's what you would write, because there is no point of intersection.
There's no point in graphing then.
That's right. The entire, write this down, line is the intersection. It's the same line. I mean, there are two lines, but they are the same line, so they're right on top of each other. So the intersection is the whole thing. So your answer, instead of an ordered pair, because they didn't cross at one point, it's the same line, so your answer is going to be this. So if it's the same line, then this is how you write your answer. Any questions about that? I got one more example and I'm probably going to set you free. Seriously. I think y'all got this.
You have a lot of boxes.
John, you will find that.
That's probably not.
Huh? Oh, gosh. Okay, let me get through this other one and then I'll show you how to check. This one, you don't need to because it's the same thing. All right. The ordered pair, this ordered pair, okay, so New said, how do we check? This is your X and this is your Y. So you would take your original equation, y equals x plus 5, and you would substitute this in there. So like you would say this is x, you would put -3 plus 5, and then y is 2. So you would substitute. -3 plus 5 is 2, therefore it checks. And then you would go back to the second, remember this second line, and you would do the same thing. Y equals -3x minus 7. That's your second line. You would take your same ordered pair and substitute it in here. So this would be 2 equals -3 times -3, minus 7. So -3 times -3 is +9 minus 7. That would be 2 equals 2. So then it checks. If y'all want to write this down, go ahead and write that down. So if you get an ordered pair, if you get an ordered pair as your answer, like they only cross at one point, you just take the X and the Y from the ordered pair and substitute it back into the original lines. This would have been line 1. This would have been line 2. And that's how you check. If they both check, you're good to go. So those of you that are writing, I'm going to let y'all write that down. Does that help? Morgan, you got it? Okay. What if, I'm not going to write all the words. We were given x plus y equals 3 and x plus y equals 7. Miranda, what would this be? All right, that's line 1. And Sophia, what would this one be? All right, so I want y'all to look at this one. You could start graphing this, and you would find something out. Does anyone see, based on last chapter, what kind of lines these are?
Parallel.
These are parallel lines. Notice, same slope,
Mm-hmm.
different y-intercept. So these are parallel lines. So your solution or your answer no solution.
So just
Do they ever cross?
no.
Therefore, there's no solution. Remember, the others, they either had one point where they crossed, and that's your answer, ordered pair. Or they were the exact same line, so they crossed on top of each other. So both the others, they're actually touching, and so your answer is either the ordered pair where they cross, or it's the equation itself. This one, they're parallel. They never cross. There's no point of intersection. Because, Franz, you better have all this written down. They never cross. Any questions? All right, I'm going to set y'all free. I've given you 3 different examples on how to do this. Each one, you're putting them in y equals mx plus b and then seeing if they're parallel. That's going to be easy. You're done. If they're the same line, that's going to be easy because you just write down the line. The only time is if they are not parallel or same line, then you have to graph and find out where they cross. So you are doing page page 281 to 282, number 16 through 30 even.
That's it?
Yep. Was it 1, 2, 4, 5, 6, 7, 8 problems?
8 problems?
Yeah.
Awesome.
Due Wednesday.
Say you wrong.
Okay. Or due tomorrow. Hold on. Let me write this down. So you have a quiz, Monday, test, Wednesday.
This one's there.
Oh, come on. Really, tomorrow? I'm going to give you a test on this tomorrow.
Okay.